Let's solve valid parentheses. This is easier to see rather than to explain verbally. So we're basically looking for a valid combination of parentheses. An open parentheses has to be closed by the same type. And you can see in the examples, this is true, this is also true, this is false because you can't close this with a bracket closing. And this is true because these match, they get closed, and then these get closed. This is a pretty popular question. We still have quite a few companies asking this, so it is very good to know. And I'll start off by saying that this problem requires a stack. I don't even know if you can use some kind of brute force to solve it. The idea of the solution is we have a stack, and as we go through the string, we add members of the opening parentheses into the stack. So going off of example 4, that means we see an opening parentheses, so we add it to the stack. We see an opening bracket, so we add it to the stack. And then once we see a closing member, we check the last member of the stack. And if it is the same opening member, then we pop it from the stack. So since this closing bracket matches with the opening bracket, then we just pop this off the stack. And then we will keep going. So we see this closing parentheses and we check the last member of the stack, and that is an opening parentheses, and that's the same member, so it's valid, and we pop it off the stack. And then at the end, if the stack is empty, that means we've matched all the parentheses, so we can return true. Otherwise we return false. First, we're going to make a dictionary. I'm going to call this hash map because that's basically what it is, of the maps between the parentheses. So I will map the open parenthesis to the closed parenthesis, and so on and so forth. Next, I will initialize my stack and then start iterating through the characters in S. The first thing we want to check is if the current character is not in the hash map. If char not in hash map. And inside here, we want to check if the stack is empty. If not stack, then we want to return false. And we return false because if the stack is empty and we are looking at one of these closing parentheses, then these closing parentheses will never have a valid opening parentheses because there's nothing left in the stack. If we add this, it's just going to make an invalid string. So if we come to this situation, that means the string is just invalid to begin with. Next, if there is something in the stack, that means it's going to be one of these opening parentheses. So we want to pop these and check what it corresponds with in the hash map. So for example, it would be this. And then we check the equality to the current character we're checking. So if hash map of stack.pop, and I'm going to say if it's not equal to the current character, then that means that the opening and closing parentheses are of different types, so they're mismatched. So we also return false in this case. All right, so those were our two conditions to check, and else we will just append the current character to the stack. Lastly, we want to return true if the stack is empty because that means we've matched all the parentheses, otherwise we'll return false. So to do that, I'm going to say return not stack. And there we go.